Okay, today we will start with our 6.3. Day 2 is on interpreting vertex and standard form, content standard. Students will be able to transform a quadratic function by replacing it with positive or negative values. Language objective. Students will work in pairs or small groups to both give and listen to oral clues about graph of quadratic functions. Right, so yesterday on day 1, we give you the graph, we give you the function, you give us the graph. Okay, today we will give you a table or a graph and you write the function for it. Right, so let's go on to our example 3. Use each table to write a quadratic function in a vertex form, then write the function in standard form. Right, so if you look at our table to give us some clue, you notice that in the previous section or module, so that these number will tend to repeat, right? So then we know that this number will be our vertex. So we know that h is going to be -2 and k is going to be a -3. Okay, so then we also need to pick this point. Well, actually, you can pick any point you want, but I think it's easier for me to use that point. Right, so the equation we have y equal to a x plus 2, remember, double negative square and -3. So we say that we pick this point here, so x and y. So all we have to do is just substitute to solve for a. So we said 1 equal to a -1 plus 2 squared minus 3. So 1 equal to, so -1 plus 2 is 1 squared, so that gives us a minus 3. So solve for it, so we have 4 equal to a. So our function in vertex form is y is equal to 4 x plus 2 quantity squared minus 3. So then from here we refer back to our day 1 to transform our vertex to standard form. So we said 4 x plus 2 times x plus 2 and then minus 3. Right, so let me erase this part out so I need more room for it. So 4 and then FOIL this out, let's give us x squared plus 4x plus 4 and minus 3 and distribute the 4 in. So give us 4x squared plus 16x plus 16 minus 3. So give us 4x squared plus 16x plus 13. Okay, so this is our standard form, and this is our vertex form. Right? Okay, so for 11, how many points are needed to find an equation of a quadratic function? So this is refer back to what we just went through. We pick a vertex h and k, and we pick another point x and y. So actually we only need we only need 2 points. Okay, so here, so that use each table to write a quadratic function in the vertex form, then rewrite the function in standard form. Okay, so here they give us the vertex already, so we see that, then we said we can pick another point, so let's try this point here. Right? Okay, so we say that y equal to a x minus 2 squared plus 5. So then y is 11, a is just a, x is 1 minus 2 squared plus 5. So this gives us 11 equal to -1 squared is 1, so a plus 5. Subtract 5, so 6 equal to a. Right, so then the vertex form is 6 x minus 2 quantity squared plus 5, so then this is 6 x minus 2 times x minus 2 plus 5, so then 6 times x squared minus 4x plus 4 plus 5. So 6x squared minus 24x plus 24 plus 5 should give us 6x squared minus 24x plus 29. Right? Okay, so let me write the vertex form is 6x minus 2 squared plus 5, and the standard form y equal to 6x squared minus 24x plus 29. Okay? So I'm going to need room for the other side, so I'm going to erase all of this. Okay, so I'm going to do this in blue. So that's our vertex. So y equal to a, x plus 2 squared minus a 7. So I'm going to pick this point here. So this gives me negative 12 equal to a negative 1 plus 2 squared minus a 7. So negative 12 equal to a minus 7 plus 7 both sides, so we have negative 5 equal to a. So we have y equal to negative 5x plus 2 quantity squared minus a 7. So then we can FOIL this out. So negative 5 is given us x squared plus 4x plus 4 minus a 7. So negative 5 x squared minus 20x minus 20 minus the 7. So the standard form is negative 5x squared minus 20x minus 27. Okay? Right, so let's have you guys try this one out on your own. Okay, so use the table, use the value in the table to write a quadratic form, then rewrite the function in standard form. Right. So this is what they mean. Actually, they wanted to have the vertex form. Okay, so I'm going to use this point here. Right, and this one, try this one out again. Okay, example 4 said write a quadratic function given a graph. Okay, so a graph or a quadratic can be used to determine the corresponding function. So example 4 Use each graph to find an equation for f of t. Example B, a rock is kicked off a cliff into the waterfall below. The falling rock's height above the water in feet is given by the function of the form f of t equal to a times the quantity of t minus x squared plus k, where t is the time in seconds after the rock begins to fall. Right, so here we're given the vertex, so we know that h is equal to 0 and k equal to 40. So we pick this point here. So our equation f of t equal to a t minus 0 squared plus 40. So we can shorten this equation to a t squared plus 40. Okay, so we pick this point. So this is our x. This is f of t. So we said 24 equal to a times 1 squared plus 40. So subtract 40 from both sides. So it gives us a negative 16 equal to a. So then our equation f of t equal to negative 16 times t minus 0 squared plus 40. And then shorten it. Simplify this to 16t squared plus 40. And we're expecting the graph to turn downward, which is a negative. Okay, and this is the same step that we just went through, so we can skip that. Okay, so number 4, identify the domain and explain why it makes sense. Well, if we go back to our graph, so then it starts from here going positive, and the domain is our time, right? So if you go back here, so then the domain will start with 0 to positive infinity, and identify the range and explain why it makes sense. If we go back and look at our graph, so then start from 40, and then it start from 40, and the graph will fall down, right? Okay, so then the range, let me change that. So the range is from negative infinity up to 40, and is including at 40 because the rocks start at 40 feet above the ground. Okay, so here, another example, you're given a graph and you are to write the function. Okay, so then here we have the vertex. So we know that h is 1 and k is 1. So then we said f of x is equal to a times x minus 1 squared plus 1. And we choose this point here. So this is x and this is f of x. So we said negative 3 equal to a. And we write an equal sign times 3 minus 1 squared plus 1. So negative 3 equal to a, 2 squared plus 1. Okay, so negative 3 equal to 4a plus 1. So minus 1 over, so negative 4 equal to 4a. So negative 1 equal to a. So then the function f of x equal to negative 1 times x minus 1 squared plus 1. Okay, and they also want us to write this in our standard form. So let me erase this part, so I need more room. So then the standard form of, so then we can say that negative 1, and when we throw this out, this is x squared minus 2x plus 1 plus 1. So distribute the negative in, so give us a negative x squared plus 2x minus 1 plus 1. So then plus 1 minus 1, they cancel out, so we have a negative x squared plus 2x. So this is our standard form of the graph. So we have a standard form and a vertex form. Right? And similarly to the previous example, now we're given a graph and you are to write a function, right? So we see that this point here is our vertex. So is 3, 4, and let's pick this point here. It's easier to work with. So this is 5, 0. Okay, so we set f of x equal to a, x minus 3 squared plus 4, and this point 5, 0, so then the function is 0 equal to a, 5 minus 3 squared plus 4, so 0 equal to, well, 3 squared, 5 minus 3 is 2 squared 4, so we have 4a plus 4, subtract 4 from both sides, so negative 4 equal to 4a, so negative 1 equal to a. So then the function in vertex form, so f of x equal to negative 1 x minus 3 squared plus 4. Right, and the one in standard form, so let me erase this. So then this gives us negative 1 times x squared minus 6x plus 9 plus 4, so then negative x squared plus 6x minus 9 plus 4 equal to negative x squared plus 6x minus 5. So this is standard form and this is the vertex form. Right, so that's the end of 6.3 day 2. We have bookwork and we need you to finish your HRW. Alright guys, so always stay safe and be good.